Hi guys, how you doing today? So today is a question and answer session for you guys. We'll talk about administrative stuff quickly. In case this is hopefully not a surprise to you, we have an exam tomorrow. Okay, the exam includes everything up to and including chapter 5.1. So all the stuff that we've done so far, all those different chapter sections up until and including 5.1. Homework due tonight by midnight for 54651. I'll post solutions for these here sometime tonight, maybe like, I don't know, late afternoon, maybe close to dinner time. I want you guys to have a chance to work on it, but I'll post solutions so you have a chance to compare it with your answers and take a look at those. I haven't posted them already for obvious reasons because they're due today, but everything else was posted last week, so you guys can have a chance to take a look at that. We also, because we have the exam tomorrow, the exam opens up, is due tonight or tomorrow. The homework is due tonight. Oh, you're right. I'm sorry. My bad. You're right. My bad. It's due tomorrow night. I'm sorry. I'm thinking tonight's like the night things are due. No, I'm wrong. The homework is due on Thursday. Like I even wrote Thursday here. Homework is due on Thursday by midnight. Okay. So, but you don't want to be working on it because, do you know you're working on it tomorrow because you want to know this stuff for when you're going to take the exam. The exam is going to open up at 1:35 in our class period, which means we're not going to have class tomorrow. Okay, so that if you, sorry, yeah, I know, sorry about that. Sorry about your blood pressure, but anyway, yeah, the exam will open up tomorrow during our class time at 1:35, okay, which means that we will have a 24-hour window to take the exam. And if you want to take it during what would have been our class time, you're totally welcome to do that. Okay, so keep that in mind. You can do that. What else? It'll close. So it opens up 1:35 tomorrow and it's open till 1:35 on Friday. The exam is set up differently than our midterm, than our quizzes. Okay, in that it is timed, the timer on the screen, I believe. And what happens is, once you start it, you have to finish it within that session. You only get one shot, okay? So don't open it until you're ready to actually take it, okay? And then make sure that, let's see, because our exam opens up at 1:30, make sure that you guys start it no later than noon on Friday. Okay, so if you started at noon on Friday, you'll have like 80 minutes to take it, right? And to take pictures and to upload all those pictures and stuff, all the tech stuff. You get 65 minutes for the exam plus the 15 minutes to do tech stuff. If you have something from the DRC, I think I probably already heard from you. We've already talked offline, so you should be okay with that. Let's see what else. I think that's about it in terms of administrative stuff. I'll put out an announcement basically talking about this tomorrow. I'll put an announcement today so that you guys can have it for reference for about what you need to do for tomorrow's test. Let's see. Oh yeah, and I think I found out in another class, one of my other classes had an exam last week, and they found that Canvas accepted only one file for uploads. So that means that if you usually like submit multiple JPEGs or multiple PDFs for your stuff, then the exam Canvas will only take one file upload. I think that maybe what I'll do is I'll put in like multiple questions. The first question will be worth 100 points, right? That's where the whole exam will be. And then the next questions will be worth 0 points. So if you have like 4 pages that you'd like to upload, if I normally work on my iPad, it's okay just to send in one long PDF. That's perfect. Just one long, that has all the different pages on it. And then PDF and JPEG are the 2 file formats that we'll accept. Allow for PDF, yeah, PDF and JPEG. Just like our homework, right? We'll take, and the quizzes will take PDF and JPEG. And so I think maybe I'll do like 4 questions. The first one is the one that's your main one, so that if you're going to do it in one file, do it on the question number 1. And then questions, you know, maybe 2, 3, 4 will be like in case you couldn't get it into one file, you'll have like 4 other options. You can do, you know, your first JPEG, your second JPEG, your third and fourth JPEG on those subsequent questions. But if you don't submit on those, don't sweat it, because it's just the first one that I need. Anyway, but I'll put this into the in an announcement so we can have it in writing so you guys can reference it. Anybody have any questions they want to ask? This is for you. Oh yeah, one more thing. The test 1 from spring 2017, you guys can ignore the questions 4 through 8. There are 9 questions on it, but you can ignore 4 through 8. This was several years ago. We used to do the class in a different order. So if you look at questions 4 through 8, that'll be good for exam 2. So these questions, we just haven't covered it yet. Velocity, area swept out, things like that. So don't worry about those questions here. But question number 9 is a partial fractions question, so you definitely want to take a look at that. Yeah, I think if we talked offline about DRC stuff, I got that information. So I think if we didn't come up with a plan on what to do, then email me like right after class, and we'll come up with a plan for what to do for stuff. Okay. Let's see. So it looks like people are asking for homework things. So we can let's take a look at homework. How many questions can we expect? You know, it's going to be on the order of the same of the exams that we've seen so far, you know, so, you know, I don't, you know, it's going to be on the order of what we've seen so far, you know, somewhere around 10 questions, maybe a little bit less. But basically the exam is set up to check all the different stuff that we've been covering, all the different topics that we've been covering, and then also something that's doable within 65 minutes. Okay. Let's see. So homework 4.5, homework number 13. Okay. So chapter 4.5, number 13. So let's take a look. Let me get out my notes. Okay. So the radius of convergence for the following power series. So we're given this power series. K equals 1, 5 to the K, x minus 1 to the K, all over K squared. And then they give us out what this polynomial looks like. This is a polynomial. Power series means we're dealing with a variable x raised to a power, right? So this is x raised to a power. This polynomial is centered at x equals 1. Okay, I can know that because x minus 1, I set that equal to 0 and I solve for x. That tells me where the center is. So this is x minus 1 plus 5 squared over 2 squared. 5 to the, third, all over 3 squared, x minus 1 cubed. And then there's a couple other terms there. So, all right, so let's go through these. So this is question 13. So this is what's our radius? And we'll come up with the center in the interval and all that kind of stuff. So part A is we're going to do the ratio test to figure out what's our radius convergence. So my ratio test says I'm going to go the limit as k goes to infinity. So on my ratio test, my operating variable is k, my index, right? So I take my next term up. So every k that I see, I go k plus 1. Divided by my current term, 5 to the k. And this is an absolute value. I have a fraction divided by a fraction. So I always like to rewrite this to group like terms together. So I'm going to get 5 to the k plus 1 all over 5 to the k times x minus 1 to the k plus 1 all over x minus 1 to the k times k squared k plus 1 quantity squared. And this is absolute value. So now from here, I can start cleaning it up a little bit. So this is going to be k plus 1 over k. So this is going to be equal to 5 times x minus 1. And then this is k squared all over k plus 1 squared. Okay, so now let's evaluate the thing that has the limit on it, right? No k's here. So this is the thing. So I've got k squared over k squared. So this whole thing here goes to 1. Okay, so we want this to be less than 1 for our, that's our criteria for the ratio test. criteria for convergence. Right, so basically what I'm left with is 5 times the absolute value of x minus 1 is less than 1. Okay, this x minus 1 absolute value, I leave it because it represents my power series where it's centered. But the 5 I can bring over. So I've got x minus 1 is less than 1/5. Okay, so this right here tells us a lot. It tells me my radius and it tells me my center. So let's write that down. So my center and my radius. Okay, I'll let you finish writing that before we go into the interval. Right, then let's do B. So B says, what are the possibilities for our interval? So remember, it's the center minus the radius, the center plus the radius. And the possibilities are, do I include the endpoints or not? So this is going to be 1 minus 1/5, 1 plus 1/5. So this is 4/5 and 6/5. So we're looking at, I include both. I don't include either. I include one of them. There, so these are my 4 possibilities. What we're going to learn in chapter 5 is how do I test whether or not which one of these is true? How do I test whether the endpoint is going to be included or not, or a combination thereof? We're going to learn that in chapter 5, and then we're going to come back to chapter 4, 5, and 4, 6, and we're going to reevaluate all this stuff. Okay, part B, part C says, let's evaluate our polynomial at different values of x. So this is x equals 1.1. So I'm going to plug that into my polynomial. So I go back up to this right here. Everywhere I see an x, I plug in 1.1. So I'm going to go 5 times 1.1 minus 1. I think they told us to use the third order, so 0.57638 is what I got for that one. I'm going to do, what do they say the next one? 0, 1, oops, 1.01. Right, and then this one I got 0.050638. And then we did x equals 2. And then this one is way off.
Professor, could you just move it a little bit to the right? It's cutting off the last couple of the answers there.
Is that okay? Let me see if I can get my camera to sit up right.
Perfect, thank you.
How's that? Let me try.
Much better.
There. Okay. All right. So part D says, how come this isn't, how come we don't really know everything? It's because we don't know f of x is unknown. Part E says we're looking at values close to and far away from the center. So our interval of convergence is equal to 4/5, which is 0.8, to 6/5, which is 1.2, right? We're centered at 1 plus or minus 0.2, right? So if I look at x equals 1.1 and x equals 1.01, those are within the interval. This one's closer to the center, so I think this would be a better estimate, but it converges for both of these values. It's within the interval. X is equal to 2 is outside the interval of convergence, which means that the error on the approximation goes way up. So, you know, if we're within the interval of convergence, then the error on the approximation is going to be small, right? Or it won't, or it'll be negligible. So that's what we're looking at here. Okay, it looks like we have a question from, I'm gonna just choose, let's just choose one of those 4.6 problems and one of those problems from 5.1, and then we'll go on. We can come back to those later, but let's try 4.6. Do you have a preference on 14 or 40? Which one you'd like? Let's see, I think that actually, you know what, 40 is actually good. 40 is actually a final exam question. I'll tell you exactly. That one's come up a bunch of times. So why don't I do 40? 14 is a lot like what we just did, but let's do 40 because that's like our final exam question. I mean, it actually has been a, you want me to do 14? All right, well, let's do them both because 40 has been a final exam question. I can think at least once, maybe even more. It's sometimes it gets tweaked to be a little bit different, but 40 comes up a lot. I see this problem a lot in the final exam. So this is chapter 4.6, number 40. And I'm gonna say this is like, this exact problem was a final exam question a few years ago. And then it gets tweaked in certain ways. So this is important to look at. So we're given the function f of x is equal to e to the minus x squared, okay? And they're saying it has no elementary derivative. However, the elementary functions involve finite combinations of certain basic functions and power series are infinite sums. So this is a lot of words, but it says find a power series antiderivative for e to the minus x. So we're looking for the derivative of what is this thing here, right? So so what we're going to do is we're going to look at substitution in our Maclaurin. Okay, so we've got a Maclaurin. So the Maclaurin for e to the x, just generally e to the x, okay, is going to equal to 1 plus x squared 2 factorial. They usually want you to do the first 5 terms. So if I want to substitute, I'm looking for e to the minus x squared. So I'm going to substitute in, everywhere I see an x, I'm going to substitute a minus x squared. So that means I'm going to plug it in here, and in here, and in here, and in here. I have to watch my exponents. So it's going to look like, I'm going to go 1 plus a minus x squared, plus minus x squared, squared 2 factorial, minus x squared cubed 3 factorial, minus x squared to the 4th, 4 factorial, so on and so forth. So I'm going to clean it up. 1 minus x squared. And then I'm going to square this. That gets rid of the negative. Remember your exponent rules over 2 factorial. This is going to be negative because I'm cubing it. X to the 6th, 3 factorial. Positive because I'm to an even power. So this is x to the 8th, 4 factorial, and so on and so forth. So this is the Maclaurin for e to the minus x squared. Okay. Now, let's see, this is our f of x. Now they want a derivative, right? So I'm going to take my derivative. I'm going to do the power rule. So this is going to be 0 minus 2x plus 4x cubed all over 2 factorial minus 6x to the 5th all over 3 factorial plus 8x to the 7th all over 4 factorial, and so on and so forth. I can make it look nice, right, by cleaning it up. Okay. Oh, I'm sorry. They asked for antiderivative. I gave you the derivative. They asked for antiderivative. My bad. Well, anyway, we have our derivative. So our antiderivative, dx. So antiderivative, I'm going to take, did they say, oh yeah, we're going to use the third order to approximate it. Okay, so antiderivative, which means I'm going to go my integration constant, right? And then I'm going to take this, I'm going to go 1 minus x squared plus x to the 4th, 2 factorial minus x to the 6th, so on and so forth. So let's do this. C plus, this is all dx, right, with respect to x. So now I'm going to go x minus x cubed over 3 plus x to the 5th all over 2 factorial times 5 minus x to the 7th all over 3 factorial times 7 plus x to the 9th 4 factorial times 9. You can come up with numbers if you want for these, but did they say where to stop? Find a power series. They didn't say where to stop, so you can just do a first handful of terms. I'll answer your question, Kartiki, in just a second because that's a great question. But let's do this. So part B says we're going to evaluate this e to the minus x squared. We're going to go from 0 to 1. So this is going to be right. We're going to take this here. I'm going to go, and they said use, what did they say? Use the third order Maclaurin polynomial from your answer in part A. So that means I'm going to be looking at, let's see, looks like I went farther out. So my third order Maclaurin is here. It's like here, basically. So I'm just going to be getting x minus x cubed over 3 from 0 to 1. Because they said to use the, to use the third order Maclaurin from part A. My third order Maclaurin, this is my, right here, my third order Maclaurin. I don't have an x cubed, but I just have even terms here. So this is my third order Maclaurin. Okay. All right. So this is what I get after I integrate it. So I'm going to get 1 minus 1 cubed over 3. And I'll just show you, we would just do 0 minus 0 cubed over 3. This is going to be 0. So it's going to be 1 minus 1/3, right, which is basically 2/3. Right. If they wanted like a higher degree term, right, I think in my answer, I went farther out in my answer on the page. I said x minus x cubed over 3 plus minus, and then I did this one here. I actually went farther out because I wasn't answering the question very well. So this is going to be 1 minus 1/3 plus 1/10 minus 1/42. And that's all going to be minus 0. And then for this one I got was equal to 0.74. Okay. So this was a final exam question a few years ago. Why did I only use x and x cubed for the third order? So why did I only use these two terms for the third order? Because the question said, use the third order Maclaurin from your answer in part A. My answer in part A is right here, right? What's the third order Maclaurin? Everything up to and including x cubed. I don't have an x cubed, I have an x fourth. So my third order is x squared, 1 minus x squared. When I integrate this, 1 minus x squared, I get x minus 1/3 x cubed. So that's why I did this. And then on my notes, actually, I have it out where I went out to the 7th. I don't know, I guess I wasn't reading the instructions very well, but I got a better approximation. So somebody asked, do we need to derive the common functions or can we just assume they are common knowledge and use them? You can do both. So let me tell you, the fundamental Maclaurins, we've got, I think we gave a list of a lot of them. Maybe it was like on the lecture examples for 4.2, maybe right at the very end. I'm trying to remember. We gave a list for things like e to the x, sine of x, cosine of x, inverse tangent, I think ln of 1 plus x. There may have been a 1 over 1 minus x in there too. I can't remember. I can't remember how many functions we gave you. They're in the book. There's like a whole bunch of them also in the book, which is I think where I got the list from. Those are the fundamental Maclaurins that we're talking about here. If you know those, go ahead and use them. Okay, and I guess technically speaking, because this exam is open book, right? Because we're remote, so it's technically open book. You just can't talk to other people or use like online solution solvers. Then you can just look those up and use them as substitutions. When we are in class and taking this in class, then you have to have it memorized, right? Or you can derive it on your own, right? So these are all just Maclaurins. So remember, right? So if you're looking for the Maclaurin, like somebody in my 9 o'clock class asked me for the Maclaurin for 1 over 1 minus x, right? So if this is your f of x, and you want to come up with the fundamental Maclaurin for it, remember Maclaurin is x equals a equals 0, right? So I'm going to evaluate this at 0. It's going to be 1 over 1. So that's my first one. My derivative So this is 1 minus x to the minus 1. My derivative is equal to minus 1 times 1 minus x to the minus 2 times my chain rule, minus 1. So this again becomes 1. My second derivative, right, is going to be minus 2 for my exponent, 1 minus x to the minus 3 times minus 1 for my chain rule. So that's 2. My third derivative, right, this is going to be minus 3 times 2, 1 minus x to the minus 4 times minus 1. So this is 3 factorial, this is 2 factorial, and so on and so forth. And so, so basically we can come up with our Maclaurin. Remember, we'll call it up to n. It's going to look like our function evaluated at 0 plus our first derivative evaluated at 0, x to the 1, plus our second derivative divided by 2 factorial evaluated at 0 times x squared, and so on and so forth, right? So these things here are just the coefficients that we would get to plug into our Maclaurin. So what I tell students, like when we're in person and you don't have it memorized, and I would say even at this point, unless you can actually just look at a piece of paper, right, then your best bet is to be really quick about deriving these things, quick and correct about deriving these functions, because until you have them completely down pat in your mind, right, and that may take like a couple classes for you to be able to see, you know, like, oh yeah, I recognize that, that's e to the x or that's cosine or whatever, then you're better off actually just deriving it so that you don't mess up on what the functions are. All right, so 14, 14 from 4.6. Okay, so this one is derivative and integral. So give me a sec. So the answer to your question is you can do both. I recommend always knowing how do you derive a Maclaurin or a Taylor polynomial. So if you can't remember what the fundamental polynomials are, right, then you can just derive it. It's not a problem. Okay, so this is 4.6 number 14. Okay, so this one we've got p of x equals k equals 1 to infinity radical k x plus 3 to the k. And we're going to write out, oops, there's a radical 2. So this thing goes on forever. So we'll write out what the polynomial looks like because we want to talk about, do they want to know, give the center and radius of convergence. Okay, so let's do the ratio test to come up with our radius, right? So I'm going to go limit as k goes to infinity, because the center and radius are going to be the same for the polynomial, its derivative and its integral. The only thing that's going to be different is the boundaries on our interval. All right, so I've got radical k plus 1 times x plus 3 to the k plus 1 all over radical k x plus 3 to the k. Okay, so let's think about how this is going to work. Okay, so k, right, this doesn't have a k in it anymore. This has a k. So k to the 1/2 over k to the 1/2, this goes to 1. So now I'm looking at x plus 3 has to be less than 1 to converge, which means this is our radius. Is equal to 1. Our center here is equal to minus 3. Okay. All right. So that'll be the same thing for our derivative and for our integral. So they want to know what's the derivative. I'm going to do it both ways, on the summation and on each term here. Okay, so when I take the derivative, this is with respect to x, right? Which means that my k is just a coefficient, right? So I don't have to worry about that. So this is going to be k equals 1 to infinity, radical k. Now what I'm doing to do the power rule, times k, x plus 3 to the k minus 1. That's my derivative. Straightforward, right? I can also do it on here, right? So then this is going to be equal to, if I take that derivative, that's equal to 1 plus 2 radical 2 x plus 3 radical 3 x plus 3 squared plus dot dot dot. And that's what I would get here if I were to sum that out. So all I did here was take the derivative of my polynomial. I did the derivative on the summation, but just by the power rule. My k was my exponent. Now this has a radius equal to 1, center equal to -3. Same thing as my function. All right, let's do my integral of px dx. This is an integral here. I go back up to my original function, okay? Don't do an integral on your derivative. You'll just, you're going to be confused. Go back up to your original function. So I'm going to do it both on with my summation. Okay, which means I'm going to get k, the radical k is just a constant term, but I need my constant of integration. So I'm going to get radical k, x plus 3. I have to increase my exponent. Oops, I forgot my summation. All over k plus 1. And then I'm going to go k equals 1 to infinity. Okay. And I can think about that too if I were to integrate each of these terms here, right? So if I were to integrate for example, right, if you can't remember how to do it on the summation, don't forget your constant of integration, right? This is going to be x plus 3 squared, right, all over, oops, sorry, all over 3, plus this is going to be radical 2 times x plus 3 cubed all over 3, plus radical 3 times x plus 3 to the 4th all over 4, so on and so forth. Sorry, squared. This should be squared. My bad. Let's see, 4.5. Let's do a couple others. So 4.5, 17. And 4.5, number 7. We'll do 4.5, number 17. Okay, you guys will have this here. Number 17. So we are given p of x equals k equals 0 to infinity, x minus 4 to the k, 7 to the k plus 1. Okay, so part A, we want the radius and the center, right? So I'm going to do my ratio test. Limit k goes to infinity. X minus 4 to the k plus 1 all over 7 to the k plus 1 plus 1. Everywhere I see a k, I substitute k plus 1 all over x minus 4 to the k, 7 to the k plus 1. So we're going to clean this up, group common terms together. So I'm going to x minus 4 to the k plus 1 k times 7 to the k plus 1 all over 7 to the k plus 2. Okay, so this is going to look like, where am I? Let's see. x minus 4 times 1 over 7. Oh, I don't have a k anymore, right? So this all kind of falls apart. So I go x minus 4 all over 7 has to be less than 1 to converge, right? I've got this 7 I can multiply. So I'm going to get x minus 4 is less than 7. So don't add 4 to both sides or anything, because this is where you're centered and this is your radius. Okay, so my radius is equal to 7. My center is equal to positive 4. Okay, so now part B says, what are our interval possibilities? So what are our interval possibilities? You've got the a minus r, a plus r, right? So do I include, so this is 4 minus 7, 4 plus 7. So I'm going to go from minus 3 to positive 11. I include both. I include neither. I include 1. That's it. Part C says, let's plug in. Okay, so I'm going to go back up to the polynomial that they, did they give me one? No, I'm just going to enumerate a bunch of terms in the polynomial. So I enumerated the polynomial out. So when k equals 0, right, what am I left with? When k equals 0, I've got, because it starts at 0, so this is going to be 1 over 7 plus, when k equals 1, x minus 4 to the 1 all over 7 squared plus x minus 4 squared, 7 cubed plus x minus 4 cubed, 7 to the 4th. Right, so that's my polynomial starting at k equals 0. Okay, so 1/7 plus 4.1 minus 4, 7 squared plus 4.1 minus 4 squared, 7 cubed, 4.1 minus 4 cubed, 7 to the 4th. And then this one, what did I get on this one? So I'm going to get, let's do this out. So I'm going to go 7 plus 9.1 divided by 49 plus 0.1 squared divided by 7 cubed plus 0.1 cubed divided by 7 to the 4th. And this one I got was 0.1449. Okay. And you're going to do the same thing, 4.01. And I got, I think when I did this one, I got 0.14306. And then P of 5, I got 0.16618. Okay. All of these are within my radius of, so D, we already know the answer. We don't have the function. E, they're all good because they're within our interval, but we'll say closer to center is best. Okay. Let's see, where are we now? 4.5 number 17. I'm trying to go through the list here. 4.5 number 16. Okay. You guys will have this here. I'm gonna turn the page. Okay, so this is 4.5 number 16. There. So we're given P of x equals k equals 0 to infinity, k factorial x minus 4 to the k all over 7 to the k plus 1. So it's similar to the one that we just did, only it's slightly different, right? So how is it different? Right, so now we have a k factorial, where before we didn't have a k factorial. Okay, so that k factorial is going to change things. All right, so let's do our ratio test. So k plus 1 factorial, x minus 4 to the k plus 1, all over 7 to the k plus 1 plus 1, all over k factorial absolute value. And let's group it by like terms. So I've got a k plus 1 factorial all over k factorial times times 7 to the k plus 1 all over 7 to the k plus 2. Okay, so let's clean this up. So I've got k plus 1 factorial all over k gives me k plus 1 times x minus 4 times 1 over 7. All right, let's go ahead and take the limit. So the limit, this is the limit as k goes to infinity, right? So I have these terms here, but I've got the limit as k goes to infinity. This thing goes to infinity. Oops, that's a bad infinity. An infinity. Sorry, that's a very bad looking infinity. That goes to infinity, which means that the limit does not exist, which means that our radius is equal to 0. We can think about this as infinity is greater than 1, right? Which means that our ratio test shows divergence. Series diverges. Okay, for all values of x except at the center. Okay, so we're going to write it up. So our radius equals 0, and our center, we can just look at our polynomial, is equal to 4. So this is what we call a point convergence.
Excuse me?
Yes.
So just to recap, so if it does not exist, then the series converges only at the center?
Yes, remember when we talked about power series convergence, we were guaranteed a point convergence. And that's because when we define our power series, we define it to be centered at a given value. So we know that the derivative and the function the derivative of our power series and the derivative of our function are equal to each other at the center. The second derivative, we went through all of this stuff like in 4.2 or 4.3, I forget. So we're deriving our power series from the function at where we're centered. So we're guaranteed a point convergence. But it's not very interesting. That just means that this power series is only going to be good if I'm right at the center. So for all other values, every time I do this, I have to reevaluate my power series, right? So I have no interval of convergence. It's just the center, right? So it's kind of a poor representation of our function, right? I mean, it's basically that this isn't going to converge. It's just at that center point. Whereas in the previous example, this one, right? So this is the one that we just did. It looks like that, but without the k factorial in the numerator. We had a pretty wide radius of convergence, right? -3 to +11 is a pretty wide range of values for which this function will be equal to its power series. Okay, whereas on this one, the function's only equal to its power series at the center point. And it's because our limit doesn't exist, right? This thing goes off to infinity, right? And so if it went off to, if I had some other number here, like if this went to, so I think we have another one like this. I don't know if we have another question like this in the homework, but we certainly did in the lecture examples. Let's say, for example, this was 1 over k plus 1. This thing goes to 0, right? So then our limit, this is 0 is less than 1, so it'll converge. But there's basically what happens is because it's less than 0 is less than 1, so it's going to converge. But that means that our radius of convergence is infinite. Right, all values of x will satisfy this. Basically our power series is equal to our function for all values of x. Whereas this one, the power series is equal to its function only at the center point.
I see.
There were three possibilities for convergence. One was at the center. One was during some interval, which we're using the ratio test to figure out. And then the third one was, is it an infinite interval? So all values of x. We think we did this. Did we do this in chapter 4.5? Maybe when we talked about the ratio test.
Okay, I see. Also, so if like the ratio test turns out to be greater than 1, then does that that means that does it diverge for all
Yeah.
values, or it still converges at the center?
So the thing is, you have to be careful because we're talking about k going to infinity, right? And so you have to think about, like, if I've got I think what's going to happen is, if you can get this equal to some finite value, right, then I'm basically looking at, I've got a finite value, and as long as I don't cancel out my x's in some weird way, then I basically have some number that I can manipulate with my inequality. It's when this thing goes off to infinity, right, when this limit doesn't exist, that my radius will be 0.
Okay, I see.
Yeah, it's a little confusing because it's like, if our limit doesn't exist, our radius is 0. If this thing goes to 0, our radius is infinite, right? And what that means is that the radius, all values of x, will cause this power series to converge. That's what we do at our fundamental Maclaurins, like our e to the x or cosine of x. Those things have an infinite radius of convergence. It means all values of x are good to go. We can represent this. That's why they call it a fundamental Maclaurin, because all of those values of x, that polynomial is equal to that function for all values of x.
Okay.
Whereas the one that we just did, was it this one? No, this one. The one that we just did, or the one we did just previously to this, was, right, we had a small interval, right? So only values of x that fell within this, right? We can see this right here. So I have a couple values that are within my interval and one value that's not, right? So the value that's not within my interval is like way out there in terms of like how good it is, you know, and the ones that are closer to our center have a better approximation value. So you want to be as close to the center as possible, but if you have a wide radius of convergence, that means that your values of x, you have a lot more going for you. And then the rest of this, part B and C, so B, our interval, is equal to just the center point, which is equal to 4. C, we're going to do like just like what we did before, which is we're going to plug in 4.1 into this, and I got what's this, is number 16, I got 0.1449, probability 0.01, I got 0.14306, and then they said 5 p of 5. I got I'm just plugging this into the polynomial. Yeah, I think I did second order or something, 0.169, so something like that. So and really, like, these are all like, you know, not so great, because this is only going to converge at x equals 4, so it'll only be equal to the function, but we don't know what the function is, so I can't even tell you how good this approximation is. How to get to the final Maclaurin polynomial from the expanded terms in exam. Yeah, give me just a second. So somebody asked about 5.1. Oh, yeah, I want to tell you guys, for 5.1, you guys can ignore questions 28 and 30. So let me write that down in red. Chapter 5.1, you can ignore question 28 and 30. This is about Fibonacci, and this one, I didn't even answer this one. So you can ignore those two, it's fine. Exam 1, version A. Is that, do you mean, Harrison, are you talking about 2019, spring 2019? Which one are you? I think you must be talking about 2019. That's the version A. Yeah, okay, great. On number 9. Yeah, I think I made a typo on the answers, the solutions I put up. So, because I found it when I did it with my 9 o'clock class, I found the typo, but we'll go over this problem here. So this is an old exam from 2019. So this is spring 2019. And we want question 9. Okay, so question 9, what's the Maclaurin series for the function f of x equals e to the x cosine of x? Now please don't do a Maclaurin for this, right? Like if your first derivative is product rule, your second derivative is going to get really big. Don't do a Maclaurin series for this. The whole point is to use substitution. And then we're going to do multiplication. Okay, so let's write down my e to the x. We know that our fundamental Maclaurin for e to the x is 1 plus x, so on and so forth. For cosine of x, it's 1 minus x squared over 2 factorial, x to the 4th over 4 factorial, and I'm not going to worry about the rest of it. They said use the first 4 non-zero terms. So now when I say e to the x times cosine of x, what I'm going to do is I'm going to substitute in my polynomials 1 plus x plus x cubed over 3 factorial times, and now my cosine 1 minus so on and so forth. Okay, and now I'm just going to do however you want to do polynomial multiplication is fine. I did this term times that, this term times that, this term times that, and then I tried to add them up. So let's do 1 times 1. So 1 times 1, 1 times x squared over 2 factorial, 1 times x to the 4th over 4 factorial. And now I'm going to do this term, x times 1 plus x times x cubed, x to the 5th over 4 factorial. Did I forget a term? 1 times, no, I'm good, right? This, okay, good. And then I'm going to do this one. It's going to be x squared over 2 factorial minus x to the 4th all over 2 factorial times 2 factorial. I'm going to get lazy and not just multiply it out. Plus x to the 6th all over 2 factorial times 4 factorial. You get the idea. Let's do this one here because I have an x cubed term I'm going to use. So I'm going to multiply this by a couple of these plus x cubed over 3 factorial. So this term times that minus x to the 5th all over 2 factorial, 3 factorial. And then I'm going farther out than I need to. Okay, so now I'm just going to start summing them up. So I've got a 1, have any other ones. So I'm going to put a check mark. Minus x squared, positive x squared, so they cancel each other out. My x cubes, oh, and x, sorry, x, that's done, x squared, x cubed. So I'm going to go minus x cubed, 2 factorial, plus x cubed over 3 factorial. We'll sum these up in just a minute. And then x to the 4th plus, let's see, minus x to the 4th all over 2 factorial, 2 factorial. Okay, so now, All right, did I do this one right? Doing these things on the fly too. X cubed, x to the 4th, 2 factorial, 2 factorial. Okay, all right. So let's check it out. So this is going to be 1 plus x. So this is x cubed over 2, x cubed over 6, right? So I'm going to subtract those out. I'm going to get minus x cubed over 3. Plus this is x to the 4th, x to the 4th all over 24 minus x to the 4th. This is just over 4, right? So this is like 6 over 24. So 1 is going to be like a minus 5 over 24, x to the 4th. And they said get the first 4 1, 2, 3, 4, first 4 non-zero terms, and that's it. Okay. I think there's maybe a typo on the answer. There's a typo on the answer for this one, and then there's a typo on the answer for 8. From the solutions that I posted last night. So that's for number 9. The number one for number 8, there's a typo for the derivative. Should be minus 3x squared. Question 6. Yes. 5 and 6. Yeah, don't worry about question 6. Listen, Question 6 looks like this. We're like, my colleagues don't ask this on the exams anymore. So I think last spring I didn't even count this question. I had it, but then I took it off in terms of counting it. So don't worry about it. We're not going to have a question like this on the exam. If you want to know how to do it or what we're trying to do, take a look at the answers, but don't worry about it for the exam. Yeah, it's probably a relief, right? I think there were some other questions that I didn't answer. 5.1, I said we don't have to do that one. 4.6, number 11. Did we do that one? I don't remember. Yeah, we can do 4.6, number 11. You guys have this one? Okay, I'm gonna turn the page. Okay, so let's do 4.6, number 11, and then we'll come back to the other one. Somebody just posted. So this is 4.6, question 11. So this is again using substitution. So we're given f of x equals cosine of radical x minus 4. A equals 4, x is equal to 4.01. So we're lucky. They want us to come up with a Maclaurin that's center, or not Maclaurin, but like we're going to use this and we're going to center it at x equals 4. Then we want to evaluate for a number close to that. So we're lucky that like the term that they're giving us here is actually where it's centered. So I don't have to worry about recentering my polynomial. But I'm going to use my fundamental Maclaurin for cosine of x, which is equal to 1 minus x to the 4th over 4 factorial minus x to the 6 factorial, so on and so forth. So I'm going to plug in, everywhere I see an x, I'm going to plug in x minus 4 square rooted. Okay, I'm going to plug it into here, to here, and to here, and so on and so forth. So cosine of radical x minus 4 is going to look like 1 minus squared all over 2 plus x minus 4 to the 4th, 4 factorial, minus x minus 4 to the 6 factorial, and so on and so forth. So now remember, this is like to the 1/2 power. So this becomes x minus 4 all over 2 factorial, plus this is 1/2 times 4, this becomes x minus 4 squared, 4 factorial, minus and so on and so forth. Okay, so this is, did they say, I don't know if they said how many terms to do, but anyway, I did 1, 2, 3, 4. And now this one they wanted to check out, part B was x is equal to 4.01. So I'm going to plug in 4.01 here. So that's going to go 1 minus. Okay, and I think I got for that 0, it was like approximately equal 0.995004167. Um, 4.5 number 2, and also so 5.1 question 4. Let's do that one. Yeah, so 5.1 question 4 is just a limit. Let me know if you guys have that all written down. You guys all have this? So 5.1 question 4 is just the limit. But I've got, you can think about it like this, right? It can break it up 2 to the n over 2 to the n. That goes to 1. This is n squared over 2 to the n. 2 to the n, exponentials dominate because they go more quickly to infinity. So this one goes to 0. So this is 1 plus 0. So this is equal to 1. So this thing converges. 4.5 number 2. Okay, let me get out my notes. 4.5 number 2. Yeah, this is the same thing. So 4.5 number 2, looks like this, right? So we're taking the limit. These first three questions are like chapter 5.1 questions. So what we do is, right, I've got the limit as n. I'm taking the limit of my nth term because this is my sequence of numbers. So I've got 5n squared plus 3 times minus 1 to the n all over 7n squared. So think about when n gets really, really big, right? 5 times 10 billion squared plus 3, 5 times 10 billion squared minus 3. This is just a plus or minus 3, right? So this plus or minus 3 goes away because it's really not impacting when n gets really, really big. So really what we're looking at is 5n squared over 7n squared, which is just the ratio of the coefficients, 5/7. So this thing converges. If the minus 1 was attached to one of my highest exponential powers, I'd be in trouble. Then this would oscillate and it probably wouldn't converge. But it's not. Okay. 6 number 11. What was the last one? 4.5 number 9 to be? Okay. So okay, yeah. Let's go ahead and do 4.5 number 9. So 4.5 number 9. All right, so 4.5 number 9 looks like this. So I'm going to go, I'm going to do our ratio test. Oh, and we're given this k equals 1 to infinity, 3 to the k all over k to the 100. Oh yeah, I think this is, I think the answer in the book is wrong on this one, but let's go through it. So we're doing a ratio test, and this is what we're given here. So I'm going to go the limit as k goes to infinity of 3 to the k plus 1 to the 100 all over 3 to the k to the 100 absolute value. So let's group like terms. So I'm going to get 3 to the k plus 1 3 to the k times k plus 1 to the 100. Okay, so now this looks like the limit as k goes to infinity of 3 times k to the 100 all over k plus 1 to the 100. Okay, this thing here goes to 1, right? So this is 3 times our limit, right? So this is like 3 times the limit k to the 100. This isn't a power series. This is just a series. Right, so this one here, I've got this is equal to 1, so this is equal to 3 total. But 3 is greater than 1, right? Which means that this diverges. Which makes sense when I look back at my original series looks like 3 to the k all over k to the 100. What we're looking at is an exponential function over a polynomial. Exponentials always go to infinity faster. So this thing is going to diverge because this is going to dominate. 3 to the k is going to dominate. So there's an error on the answers in the back of the book because I think they said it converges, but this number 9 diverges. Okay. All right, you guys. So I think that's about it for today. I'll have office hours tomorrow, so you're free to come to office hours because your exam won't have started yet, so you can come and ask questions on stuff if you want to ask me some last minute stuff. Otherwise, I hope you have a great weekend and good luck on the exam. And don't forget, homework's due tomorrow by midnight. Okay. Take it easy, guys. Have a good weekend and good luck on the exam.
Thank you.
Bye.
Thank you.
Bye, guys.
Thank you.
Bye.